Bismillahirrahmanirrahim. Welcome to the third part of the 12th lecture of Statistics and Probability Theory. We will continue with the topic hypergeometric distribution. A carton contains light bulbs in which 3 are defective, and total we have 24 bulbs in the carton. So as you can see from here that total bulbs in the carton are 24, which means capital N is equal to 24. What is the probability that if a sample of 6 is chosen at random from the carton of bulbs, X will be defective? So here they are saying the random variable associated with the defective bulbs. So it means the defective bulbs in the carton are our number of successes, which are 3 in numbers. It means 3 is equal to K. So how many non-defectives are there? As total number of bulbs are 24 and total number of defectives are 3 and total number of non-defectives will be 24 minus 3, which is capital N minus K, which is equal to 21. What they are saying that 6 bulbs are chosen at random, it means small n will be equal to 6. So X will be the number of defectives. So according to the hypergeometric distribution, probability mass function will be K C X n minus K and small n minus X divided by 24 C6. It means it is capital N C small n. So this is the probability mass function of hypergeometric distribution. On substituting the values, we will get this form of the probability mass function. So if you want to find that probability that there is no defective, and as X is representing the number of defective, so we will substitute X is equal to 0, which is equal to 3C0 21C6 whole divided by 24C6, which is equal to 0.40316. That is the number of defective probability of the number of defectives. Next example, suppose that automobiles arrive at a dealership in lots of 10 and that for time and resource considerations, only 5 out of each 10 are inspected for safety. The 5 cars are randomly chosen from the 10 on the lot. If 2 out of 10 cars on the lot are below standards for safety, what is the probability that at least 1 out of 5 cars to be inspected will found not meeting the safety standards? So here we have that there are 10 cars in there are 10 automobiles in a lot, that means capital N is 10, and they are saying that if the 5 cars are randomly chosen from the 10 on the lot, it means the randomly selected sample is small n, which is 5. And as we are interested in finding out the cars which are not meeting the safety standards, so it is written here that if 2 out of 10 cars on the lot are below standards for safety, so it means here k is equal to 2. So what we have to find? We have to find that at least 1 out of 5 cars are to be inspected will be found not meeting the safety standards, as we are interested is in the cars who are not meeting the safety standards. So we associate our random variable with the cars which are not meeting the safety standards. If x is equal to 0, it means there is not any car in the uh, selected sample which is not meeting the safety standard. So according to the PDF probability mass function of the hypergeometric distribution, which is in the form of this KCX, here we have k is equal to 2 and capital N is equal to 10, small n is equal to 5. So they are saying that at least 1 out of 5. So they are specifying the lower limit that minimum 1 car should not meet the safety standard. So what we substitute? We substitute x is equal to 1. So 2c1, 10 minus 2, 5 minus 1, whole divided by 10c5, this would be 0.556. That is 1 car which is not meeting the safety standard. This is the probability of 1 car not meeting the safety standard. But what we have to find? We have to find the probability that at least 1 out of the 5 cars. So this is this lower limit. You can go above this as much as you are allowed. So we have substituted x is equal to 2 here. That is the probability of 2 cars not meeting the safety standards, which is on substituting and solving, you will get 0.222. So this is the probability that 1 car will not meet the safety standard. This is the probability that 2 cars will not meet the safety standards. And as you have to find out the probability that at least 1 out of the 5 cars will be inspected and found that not meeting the safety standards, so we will add both the probabilities, probability of 1 car not meeting the safety standard plus probability of 2 cars not meeting the safety standard, as the word at least is used here. We cannot go further as we substitute here x equal to 3 and find out the probability of 3 cars not meeting the safety standards, because it is written here that only 2 cars out of 5 cars are below the standards for safety. So we are restricted till 2. So there are only 2 cars in the lot which are not meeting the safety standards. So when we say that what is the probability that at least 1 out of 5 cars are not meeting the safety standards, so probability of x is equal to 1 plus probability of x is equal to 2, which is equal to 0.778. So this is the probability that at least 1 car is not meeting the safety standards. We have to stop here at probability x is equal to 2 because there are only 2 cars in the lot which are not meeting the safety standards. Mean and variance of hypergeometric distribution. As this is the hypergeometric distribution is the one of the it is matched with the binomial distribution. The difference between the binomial and hypergeometric distribution is that binomial is done in binomial, the experiment is done with replacement, and in hypergeometric distribution the experiment is done without replacement. So as we know, the mean of the binomial is n into p. So here we substitute K over capital N instead of P, because we know that P is the probability of success, and we know that the probability's definition is number of favorable outcomes divided by total number of outcomes. So we know that K is representing the number of successes in the sample space or in the population. So it would be K, the number of favorable outcomes, and total number of outcomes are capital N. So this is P is equal to K by N. So as we know mu is equal to N over P, so we will substitute K over N instead of P. And as we know that variance of the binomial is sigma square NPQ, where Q is 1 minus P, so this would be in the form N into P into 1 minus P, and this is N, this is P, this is 1 minus P, and this factor will come along the variance because of the without replacement sampling. So this is the variance of the hypergeometric distribution. So now if you want to find out the mean in this particular example, what you will do, you will simply substitute mu is equal to N into K over capital N, which will be equal to 5 into 2 over 10, which will be equal to 1. So this is the mean of this particular scenario or this particular random variable, that the number of cars not meeting the safety standard. So this is representing that there is on average one car in a lot which is not meeting the safety standard. Similarly, you can find out the variance of the random variable as well, which is equal to 10 minus 5, 5 divided by 10 minus 1, as it is n minus n over n minus 1 into 5 into, as it is k over n, so it is 1, as we know, 2 by 10, and it will be 1 minus 2 by 10. On simplifying this, you will get the variance of the hypergeometric distribution for this particular statement or for this particular example.